GATE 2017 Civil Engineering Set 2 Question 24. The infiltration capacity of a soil follows the Horton's exponential model F equals C1 plus C2 e power minus kt. During an experiment, the initial infiltration capacity was observed to be 200 millimeters per hour. After a long time, the infiltration capacity was reduced to 25 millimeters per hour. If the infiltration capacity after 1 hour was 90 millimeter per hour, the value of the decay rate constant K in hour inverse needs to be found. The relevant NPTEL reference has been cited. When it comes to the Horton infiltration curve, it is given by F equals C1 plus C2 e power minus kt. Another format that is used is Fc plus F0 minus Fc into e power. To visualize this on the coordinate system, we represent the infiltration in millimeters per hour on the y-axis and time on the x-axis in hours. So initially, when time is 0, F is given by a value of C1 plus C2. As here this power becomes 0, so e power minus kt becomes 1. So that is the initial value of infiltration C1 plus C2. When time tends to infinity, e power minus kt turns to 0. So the value of F when time tends to infinity becomes C1. So it starts with a value of C1 plus C2, and with infinity it stabilizes at a value of C1. In this case, we have been given the Horton's infiltration curve, that is C1 plus C2 e power minus kt. Initially, when time is 0, the value of F is mentioned as 200 millimeters per hour. As we saw in the previous slide, initially the infiltration is C1 plus C2, so that will become equal to 200. And when t tends to infinity, that is after a long time, the value of infiltration is given as 25 millimeters per hour. So using this, C1 would become a value of 25. So solving 1 and 2, we would get C1 as 25 and C2 as 175. After a time of 1 hour, the value of infiltration is mentioned as 90 millimeters per hour. So substituting that value, we would get 90 equals 25 plus 175 e power minus k. Here t is 1. Solving this, we would get 65 by 175 equals e to the power minus k. This would give the value of e power k as 2.692. Taking natural log on both sides, that is ln of e power k equals ln of 2.692. The value of k would turn out to be 0.99. So the decay rate constant in hour inverse was found out as 0.99. The relevant NPTEL reference has been mentioned.